All right, this screencast is to analyze a one-way table. The data is called call drinks. We have 3 categorical variables, and the one that we're going to focus on is called frequency, so it's that second column. If we look at the variable view, you can see the labels. Let's see if I can open that up. There you go. So this is data that was taken from a survey at the University of Arizona asking students about drinking. So this frequency question, they had 4 options when they answered the question. How frequently do you drink? None. They never drink is number 1. Once a month, number 2. Twice. I think number 3 is actually twice or 3 times a week. And then 4 is more than that. So back to the data, you can see it's a rather large data set, and there's your 1s, 2s, 3s, and 4s. Here's what we're going to do. We are going to, we've been given some exact proportions. The null hypothesis will be, sorry about that, I had to pause it so I could write this up for you. All right, so here's what the null hypothesis is going to look like. Okay, let's say the University of Arizona did the same study a few years back, and here are the proportions that they got. For the 4 categories, the proportions are 0.15, 0.15, 0.50, and 0.20. So this is never drinks, once a month, 2 or 3 times a week, more than that. The alternative is that at least one proportion differs, and we'll do this test at the 0.05 level. Okay, so here's how you do this. Now again, SPSS is very specific in the way they want this done. So analyze non-parametric tests, legacy dialogues chi-squared. So I'm going to let that sit there for a minute. Analyze non-parametric test, legacy dialogues chi-squared. The variable that we're interested in analyzing is frequency. Now, if I just wanted to know if all the categories had the same proportions, then I could leave this here. But that's not what I want. So what I need to do is I need to enter in those proportions from the null hypothesis, and I have to enter them in the order that is expected by SPSS, which is numerical or maybe even alphabetical order. In this case, it's numerical. So category 1, that proportion goes in first, and that's 0.15, and then you add it, and then 0.15 again for the next one, stays the same, and then you add it, and then the next category was 0.50, and then 0.20, and that's where we got them in that order: 15, 15, 50, 20. And then that's it. I mean, the options, if you want descriptives, but we don't really need any of this. So we just say okay. And there it is right there. So here are your observed counts. This is just a tally. Here are the expected counts. Each one of these values comes from taking that proportion from the null hypothesis and multiplying it by the total. So 98.6 is 0.15 times 657, and so on. You can see how these 2 expected counts are the same because their proportions in the null hypothesis were the same. Our residuals are here. There's your biggest residual right there. So there's your biggest contributor to the chi-square test statistic. More students are moving out of this category at the University of Arizona, and it looks like maybe they're moving into this more category. Our observed is much greater than our expected here. So our chi-square test statistic is 23.881 with a p-value of 0.000. So we reject the null hypothesis. And then here's that warning I was telling you about. In fact, it doesn't say warning here, but if any of our expected cell counts were less than 5, you'd get a warning here. Here it tells us actually 0 of our cells have expected cell counts less than 5.